what I do is I focus on just this and this. The difference between these one and the previous example is I just had one number before, 123 or 8 in the example we're talking about. This is a whole expression. But what I focus on is just the highest power of x in this expression, and how many times, what have I got to do to that, effectively, to get that. If I look back at this, another way of thinking about this division might have been, what have I got to do to 8 to get 36? I've got to times it by 4. What have I got to do to 123 to get, in the end, 813? I've got to times it by 6. So I've got to get that to that. What have I got to do to x squared to get x cubed? I only focus on the first term in the expression I'm dividing and the first term in the expression I'm dividing into. What have I got to do to x squared to get x cubed? Multiply by x. Multiply by x. What is x times this expression? What is x times, effectively, write it down here somewhere, x squared plus x minus 2. As an aside, or in your head if you're feeling confident, what is x times this whole expression? Minus 2x, yeah. I put that underneath. X cubed minus, plus x squared minus 2x. And then I find the remainder. Because I've asked myself the question, what have I got to do to get x squared to become x cubed multiplied by x, I know that they're going to be the same. In fact, they've got to be the same, because that's what I hope is going to happen. I work out the remainder by subtracting this expression from this expression. X cubed, take away x cubed.
Oh, I thought you were just going to take x cubed away from that whole expression.
No. I can only, you remember when we're talking about algebraic expressions, I can add or subtract only like terms. So when I work out the remainder, I can subtract cubic terms from cubic terms and square terms from square terms, but not anything else. So when I work out the remainder, I subtract cubics from each other, and hopefully I'll end up with nothing. Minus 2x squared minus another x squared, because I'm subtracting this, remember, this is like minus all this. So minus 2x squared minus x squared is minus 3x squared. Minus 2x squared minus another x squared is minus 3x squared. Minus 4x minus 2x is plus 2x. Minus 4x plus 2x is minus 2x. That's my remainder. For polynomial division to work, it's designed so that you gradually get rid of the terms going from highest power down. So I design it by asking myself, what do I times x squared by to get x cubed? X. I ensure that this term is the same as that, so when I subtract that disappears. That's always got to be 0. And there's my remainder. Now I ask myself the question again, what do I times x squared by to get minus 3x squared? Answer. Minus 3. What is minus 3 times x squared plus x minus 2? Minus 3 times x squared is minus 3x squared. Minus 3 times x is minus 3x. Minus 3 times minus 2 is plus 6. Be really careful with negatives, double negatives when doing these things. So, what do I times x squared by to get minus 3x squared? Minus 3. That's what goes at the top. What goes underneath? Minus 3x squared minus 3x plus 6. And bring this minus 4 down, so that's here, that's the next one. And then I work out the remainder. Again, it's designed so this minus 3x squared minus 3x squared is plus 3x squared is 0. Minus 2x minus, as I'm subtracting this, minus 3x is plus 3x, minus 2x plus 3x is plus x. And the last one, minus 4 minus 6 is minus 2. Now, I look at my remainder, and if there are no other terms to bring down, look at my remainder, and the power of my remainder is less than the power of the thing I'm dividing into. So that's when I stopped. It's now smaller than x squared, so that's my remainder. So the answer is x minus 3, that's what my answer was, x minus 3, remainder, x minus 10 over x squared plus x minus 2. So I add that remainder on, and that's what my final answer is.